Hi guys, today we're going to be doing a lesson on thermal decomposition. But first, what I would like you to do is have a go at this starter. First, I'd like to answer the question, what is a fuel? Then I'd like you to answer, what are the products when fuels are burned? Next, I'd like to write the word equation for the combustion of petrol. Just the word equation, don't worry about the symbol equation. And then extension, quite a tricky question. Yusuf weighs a log and records its mass. He then burns the log and weighs the ash left behind afterwards. He finds that the mass of the ash left behind at the end is lower than the mass of the log. Why is this? So pause the video here, give yourself 5 minutes at least to have a go at all of those questions. Okay, before we move on to the answers, just going to whiz through what the learning objectives are, what we'd like to know by the end of this lesson. I'd like you to be able to state what a decomposition reaction is and describe the products of decomposition reactions. Next, I'd like you to be able to identify when a decomposition reaction is happening, be able to pick them out from a list. Next, I'd like you to compare decomposition reactions with combustion reactions. So that word compare means, say, similarities and differences. And last but not least, I'd like you to be able to write the formula equations for decomposition reactions. Okay, so answers. What is a fuel? Well, a fuel is a substance that is burned to release energy. So we use them to release energy. For example, in a car, we put petrol in it, and in the engine, it is burnt or combusted to give the car enough energy to be able to move. Okay, so we do very similar reactions if you have a fireplace or if you light a fire. It will give out heat, which is a type of energy. Okay. Next, what are the products when fuels are burned? So carbon dioxide and water are the products. Now we don't always form both of those. More often than not we form both, but there are some reactions where we'll just form one or the other, as we'll see later. The word equation for the combustion of petrol. Well, we know that we're going to produce carbon dioxide and water. We've just spoken about that. And the only missing link there is to know that in combustion reactions, you have to react the fuel with oxygen. So we'll have petrol plus oxygen goes to carbon dioxide plus water. Now, last but not least, the extension question. So when a log burns, it's undergoing a combustion reaction. And we know from the question above that that means it will react with oxygen to form carbon dioxide and water. Now both of those are given off as gases. Okay, so the log will have lost most of its mass as a gas. So all the ashes is leftover stuff that didn't get given off as a gas. It's leftover solids. Okay, so it's going to weigh a lot less than the log did to begin with. Okay, so if you get out your homework from last week and green pens, we're going to go through some answers. So first thing you had to do was fill in the gaps of that gap fill. And that should read, combustion is another word for burning. Combustion reactions always require oxygen as a reactant and often, but not always, produce carbon dioxide and water, although they will always produce one of those two, as we'll see. Combustion reactions always give out heat. We use combustion reactions for energy. Okay, so that's 6 marks, 1 for each correct gap fill. So which of the following are combustion reactions? So you have to be able to identify the reactions where a fuel is reacting with oxygen to produce carbon dioxide and water, or either just carbon dioxide or water. Okay, so the 3 highlighted in red there fill that criteria. So propane plus oxygen goes to carbon dioxide and water. Hydrogen plus oxygen goes to water. And last but not least, CH4 plus 2O2 goes to CO2 plus 2H2O. So O2 here is our chemical formula for oxygen gas. CO2 is carbon dioxide because there's 2 oxygens here. We can see by this little 2. and then H2O is the chemical formula for water. So how do we know which was which? Well, we've kind of already hinted at that. If the reaction shows a substance reacting with oxygen to form water, carbon dioxide, or both, it is a combustion reaction. So 1 mark for noticing that we need to react it with oxygen, and 1 mark for saying that we need water and carbon dioxide or both in there. Okay. Last but not least, another tricky question. So on Mars, the atmosphere is 96% carbon dioxide and there isn't any oxygen. An astronaut tries to light a campfire on Mars but is not able to. Write a short letter to the astronaut to explain to her why she is not able to start the fire. So the fire will not start on Mars as the atmosphere does not contain enough oxygen. So 1 mark for saying that, because it's mostly carbon dioxide and we've said up here that there isn't any oxygen. And then 1 mark for realising that all combustion reactions require oxygen. So if we want to make a campfire and burn something, we need oxygen. Our final mark there is for laying it out as a letter. So addressing the astronaut, dear astronaut, and also including good punctuation and grammar. So that's out of 3. Okay, on to thermal decomposition. Now, I'm sure a lot of you are thinking that seems like quite a complicated set of words. So what we're going to do is we're going to break it down. So first things first, what does thermal mean? I'd like you to make a mind map of what you think thermal means. Okay, where might you have heard it before and what might it mean? So pause the video here, give yourself 1 minute only, make yourself a quick mind map. Okay, here's some images for those of you who are struggling in that minute. Give yourself 1 more minute to see if you can add anything based on the images that I've added on the slide there. Okay, so what thermal is it's anything to do with heat. So up here we've got thermal imaging, which is where we use heat to be able to see things. So here we can see bats, even though this shot was probably taken in the dark. We've got thermal clothing, which is designed to keep you warm, and a thermometer. So that therm at the start of the word thermometer shows us it's to do with heat. Okay, we're going to do the exact same thing for decomposition. If something decomposes, what does that mean? So make yourself a mind map. Again, give yourself about a minute. And again, here's some images that might be able to help you with what decomposition means. Give yourself 1 more minute. So what decomposition is it's to do with breaking things down into smaller parts. So we've got this apple here is decomposing, it's being broken down into smaller parts. Okay, so we know what thermal means, it's to do with heat. We know what decomposition means, it's to do with breaking things down. So now we're going to put that together. So thermal decomposition is a type of chemical reaction where one compound breaks down, so decomposes, it breaks down to form 2 or more substances when it is heated. So when it's heated, that's where the thermal comes in. So I would like you to write this down. If that's too much for you to write, I will have attached a gap fill that you can print off and just fill in those gaps, whichever's easier for you. Okay, so unfortunately, because obviously we're doing this over a video, we're not actually going to be able to do the practical, but we are going to watch a video of it. So what the practical is all about is we're going to actually try and thermally decompose copper carbonate and prove that it has been decomposed. Okay, so it's all well and good talking about thermal decomposition. Let's see if we can actually do it and prove that we've done it. So how are we going to do this? We're going to weigh out about 2 grams of copper carbonate and place it into a crucible. A crucible is just like a little clay pot that you're going to see in the video. That's the thing that's actually going to hold the chemical, the copper carbonate. We're then going to set up a Bunsen burner and close the air hole to produce a blue flame. So with that Bunsen burner, we're also going to have a stand, a tripod, so our crucible can sit in that. Next, we're going to heat up the copper carbonate gently until we see a colour change, and then we're going to heat it for a couple more minutes to make sure the reaction is complete. Then we're going to record all of our observations. Okay, so that's something that you're actually going to do with me. Okay, we're going to record our observations. Then we're going to allow the apparatus to cool, weigh the product and compare it to the mass of the reactants. Okay, so before we do any practical, we need to think about the safety. So obviously in this practical we're handling harmful chemicals and using Bunsen burners. So what I would like you to do is write down in your books, what safety precautions do you think that we need to take? And I want you to write this down. Pause the video here, give yourself about 5 minutes to write everything that you can think of. Okay, so the first one is that copper carbonates and copper oxide are harmful. We said up here we're handling harmful chemicals. Okay, so if they're harmful, clearly we're not going to consume them. That one's quite obvious. If any gets on your skin, wash off with plenty of water immediately. We're going to wear our lab coat and goggles at all times to prevent any getting on our clothes or skin and any getting in our eyes. There's hot equipment and a Bunsen burner. We know that if we touch hot equipment, it can burn our skin. So we're going to handle with care, and we're not going to touch anything that we still think is hot. Last but not least, we're going to be using glassware and ceramics. So this can cut skin if broken. So what we're going to do is we're going to keep it in the centre of our desks to make sure it doesn't break, and we're going to handle it with care. And any hair, long hair or headscarf should be tied back and tucked into our lab coat. Okay? Here's a little picture to help us see what precautions we need to take. It's our goggles, our gloves and our lab coat. Although in this situation we're not going to use gloves because we're handling hot equipment. So if we handle hot equipment with gloves, it can actually do more harm than good, as it can just burn onto your skin, which is obviously not what we want to do. So anytime we're using something hot, we do not use rubber gloves. Okay, now we're going to watch this video through carefully, and we're going to record our observations in our book under the heading Observations. So an extension for those of you who are able to do it, I want you to write what you think will happen to the mass of the solid over this reaction. So what is the mass of our solid product compared to the mass of our solid reactant? Okay, so we're going to watch this video together.
Another type of chemical reaction which comes up commonly in common entrance chemistry is thermal decomposition. That is the breaking down of a chemical compound by heating. The green chemical in this crucible is copper carbonate. When it is heated, it breaks down to form black copper oxide and carbon dioxide. As the reaction proceeds, bubbles of carbon dioxide rise up through the black copper oxide powder. The reaction is now complete.